we practiced in the past, it composed of nitrogen and oxygen, and the heat of formation for nitrogen and oxygen is what?
71.29.
0. There is no heat of formation for the elemental form of gas oxides. So heat of formation for, that's why I'm writing it in terms of A. You don't want to go back in time. You already understand that air is composed of nitrogen and oxygen. And since the heat of formation for these elemental forms, there was no heat generated. We never generated those. These are gases that already existed in nature. So this is equal to 0. Now, for the fuel, most likely you have a hydrocarbon of some sort. You're already familiar with the hydrocarbon process, that it's some C multiplied by H. You're after the H. It might not have a C at all if it's hydrogen. Do I have the heat of formation? No. But I have some form of heat of formation because I started with C and H, and I combined them together. Right? So heat of formation for fuel, assuming we're using hydrocarbons, so I have heat of formation for my fuel here. And the heat of formation that is associated with my combustion process. So different than we've done before, because we don't need to keep outlining the specific species anymore. We understand it, we already reviewed it, we've done quite a bit on it. All right, so now that we have this, then Q out is equal to m dot f, the heat of formation of fuel, minus m dot a plus m dot f, the heat of formation of products, divided by, because I want the heat of combustion in terms of my fuel, so m dot f is going to equal to the heat of combustion, which we're after, the formation of fuel minus, now if I go MA plus MF, I could say, well, that's equal to 1 plus F divided by F multiplied by heat of formation of products. This will come out into kilojoules per kilograms of fuel.
You move it up.
Oh, sorry. So all I'm doing is repeating the same exact process that we've done before for reacting mixtures. All I'm doing is essentially lumping in air, fuel, and products. So we're more universal for my propulsion system. But we already know the decomposition of this. We already know the decomposition of this. We already know the decomposition of this. If I have hydrogen, then I have water and CO2 that's being produced here. If I have methane, then I have water and I'm sorry, did I say CO2? I think I said CO2. You only have, with hydrogen and oxygen, you got water and nitrogen just passing through, right? If I have methane, then I have H2O, CO2, and nitrogen just passing along. So that's the exact same process. Actually, right now, you realize that actually your working fluid is what?